Thrust-to-weight ratio is exactly what it sounds like. Thrust is the force generated by the rocket engine, which lifts the vessel up and off the ground. Weight, on the other hand, is the primary downward force acting on the vessel, counteracting any upward thrust. So if the thrust-to-weight ratio is less than 1, that means weight overpowers thrust. In other words, you can't fly. You need thrust to overpower weight in order to launch. In this example, I've assembled a rocket whose thrust-to-weight ratio is below 1. Observe the green number labeled TWR over on the right-hand panel near the mouse cursor. When I ignite the engine, it will not lift off. However, in its attempts to fly away, the rocket is burning fuel. When fuel is expended, the rocket actually gets lighter. You can see the thrust-to-weight ratio gradually rising, and eventually the craft will have spent enough fuel to be light enough to actually take off. Controlling the throttle of a liquid engine using the shift and control keys will enable me to manipulate the rocket's thrust-to-weight ratio towards a relatively safe and gradual landing. Notice how maintaining it at around 1 will allow me to hover as well. After all, when thrust and weight are equal, the net force is approximately 0, and the rocket will neither ascend nor descend. Thrust-to-weight ratio is not only useful to know during takeoff, but also during landing. Not all celestial bodies support parachute usage because parachutes need air. To land on the moon, for example, your descent must be carefully controlled by manipulating thrust-to-weight ratio.